We have chapter 10.5, the Pythagorean theorem. Focused learning target is I can solve problems by using the Pythagorean theorem. In a right triangle, the side opposite the right angle is called the hypotenuse. The hypotenuse is always the longest side, and the two other sides are the legs. So if we look at this triangle here, this angle here is the right triangle, signified by that little box there. The side opposite the right angle is here, it's side C, and that is what we call the hypotenuse. The hypotenuse is the longest leg, longer than leg A and leg B. Right, so these guys on the side are called legs, leg A and B. And so the Pythagorean theorem gives us the equation c squared is equal to a squared plus b squared, and this only works in triangles with a right angle. Okay, so let's go ahead and use it to solve a problem. We're given this triangle where we have leg A and we have leg B, but we need to find the length of leg C, the hypotenuse. So how can we do it? We just plug into our equation. So we get c squared is equal to leg 1 squared plus leg 2 squared. We work out that math and we get c squared is equal to 64 plus 36. We simplify and combine our like terms, we get c squared is equal to 100. Now, to solve for c squared, we need to square root both sides of the equal sign. Since we have two c's as factors under the square root, one of them can come out. We get c is equal to, and 100 is a perfect square. Right? So 10 times 10, so the 10 can come out, and we get c is equal to 10. All right. So now we're looking over here, and let's go ahead and solve this second problem. In this case, we have C, we have the hypotenuse, but we don't have leg A. But that's not a problem. We'll solve it the same way. So we'll say C squared is 16 squared plus A squared plus 12 squared, which is the B squared. All right, now we'll go ahead and work that out. And what is 16 squared? 16 times 16 is 256. Okay, so 256 is equal to a squared plus 144, or 12 squared. And then I'm going to solve for a, so I minus 144 on both sides. And what do I get? I get a 211. Is that right? Yeah, 211 is equal to a squared. Man, I feel like I'm doing something wrong because that doesn't sound right. Yep, that's it. So anyhow, we're solving for a, so we take the square root of both sides, and on one side we get a is equal to the square root of 112. And can we simplify this? Well, let's go ahead and turn it into its prime factorization. So 112 is even, so we can get a 2 out of it. Let's go ahead and do that over here. Square root 2, which means 112 divided by 2 is what's left over if we take a 2 out of it. We have 56. 56 is even, so I'm going to take another 2 out of it. So I'm going to divide 56 by 2, and we have 28 left over. 28 is even, so I'm going to take another 2 out of it, divide it by 2. 14 is even, so we'll take a 2 out of it, and that leaves us with a 7. Right? So this is the prime factorization of 112, and that's going to equal to a. So we have two 2's, and we have another two 2's, right? 7's all alone. So one 2's coming out, and another 2's coming out, so it's going to be 2 times 2 is equal to a, or 4 is equal to a, right? A is equal to 4, and that's my final answer. Oh my goodness, that's not my final answer. I forgot I'm on my square root 7, right? So maybe I can put an x here, and I could say, where should I put it? A is equal to 4 times square root 7, like that.